Hello and welcome to this look at population geography. In this lecture we'll cover a few key concepts, including population geography. We'll describe what it is and how we study different population trends around the world. We'll then look at the demographic transition model. This model is very helpful when we discuss how a country experiences economic development and how economic development and gender equality lead to smaller population sizes, or at least growth initially. We'll then wrap up this look by talking about population pyramids. I encourage you to use the worksheet posted to Blackboard as we go through this lecture so that you could draw and map the demographic transition model, and then you could plug in the key concepts and factors and issues associated with the population pyramids. You'll notice the cartogram on the right hand side of this slide that shows our different countries around the world, and you'll notice China and India are largest in the middle. You'll notice the United States is significantly smaller, but one of the larger circles. This type of cartogram shows us population sizes by country. If we take a look at another map that maybe is a little more recognizable, we'll see that China is in fact the largest country in the world in terms of population, with India coming in a close second. These two countries combine for over 35% of the world's population. So when we look at population trends around the world, it's important to note that Asia in particular holds the most people. You'll notice going around this wheel, we have the United States, Indonesia, and Brazil. So we only have 5 countries with over 200 million people, and 2 of those countries have over 1 billion. It's expected that this century, India is going to surge ahead of China and become the country with the largest population in the world. When we look at how many people are on Earth, we could count them. We do count every year. One of our matrices looks at July 1st as our cutoff, and July 1st of 2019 we had 7.6 billion people on Earth. We often ask ourselves, when we look at this tremendous size and rate of growth, is the question, are there too many people on Earth? And it's a complicated question. It's not just a simple number. In this chapter, you'll read about Thomas Malthus, who experienced rapid population growth in England a couple hundred years ago. And Malthus came up with what's called the Malthusian dilemma that looked at resources able to sustain a population. A simple answer to this question is, if we all lived like Americans, no. This population size and the current rate of growth would not be sustainable. But we don't all live like Americans. So we're going to see the population continue to grow, and we anticipate that growth will go through at least the next generation, at least the next couple decades, where we may reach a tipping point in our population overall. Our global population will start to trend downwards, will start to shrink a little bit. And when we get to the demographic transition model, we'll look at the reasons for that change. In the United States, today we have around 330 million, and you'll notice here that we're less than 5% of the global population. We've talked about our influence on culture before when we looked at cultural globalization, and we also, coming up, will look at our effect on resources, both our consumption of resources and also some of the innovations that have been made to support a much larger global population. Again, just to reiterate, our 2 countries with the largest populations, China and India. When we look at the trajectory of population growth around the world, we see that our population was very slow growing early on. By AD 1, or current era 1, there was believed to be about 200 million people on Earth. 1,000 years later, the global population doubled to 400 million. And then you'll see by 1500, we only added 458 million. So while today we anticipate our population to continue to grow, we have hit what are called bottlenecks, times, periods, eras, where our population has shrunk or constricted a little bit. And between 1000 and 1500 current era, we experienced what's known as the Black Death. It's a plague that spread across Europe, spread into Asia, impacted our population centers. And the map on the right hand side of this screen shows the diffusion of the Black Death over time. Right now, a lot of people are tracking the COVID-19 pandemic and seeing how it started in China and it's impacting countries around the world. Now, if we go back 700 years, we recognize that we didn't have the same type of globalization, but we still had global connections. And what we're looking at here on the right-hand side of the screen is the Black Death starting along the Silk Road, believed to be transmitted from animals to humans, like many of our viruses today. And as the Black Death spread, this pandemic is believed to have killed up to 40% of the population. So this type of pandemic is very alarming, and this type of pandemic creates a significant bottleneck in global population. Now, we don't anticipate these types of declines with the current pandemic or a future pandemic, but it also points out that we can't just say the population will continue to grow based on birth rates and death rates without intervening obstacles. So we get back on track by about 1500, and from there we experience what's called the Columbian encounter. And this involves colonization and exploration of the Americas primarily by Western Europeans. And during this Columbian encounter, it's believed that around 80% of the native populations in the Americas were killed when they came into contact with Western European colonists, Western European explorers, people from around the world. And the reason this occurred was because the native populations had no immunity to diseases like smallpox, the common cold, that were brought over to the Americas from Europe. So this was another bottleneck when we contracted, when we lost global population. So by 1700 current era, we added about 200 million more people over 2 centuries. Again, not rapid population growth. By 1750, we started to see our population accelerate a little bit. We started to get into the early ages of medicine, the early ages of industrial revolution. In 1804, we reached 1 billion. This was a landmark. This was a benchmark in global population growth. It took us 123 years to double that population. So in the 1920s, we reached 2 billion. And you may recall from the beginning of this lecture that today we're at about 7.6. 1959, only 32 years later, we added another billion. 15 years later, we added another billion. 13 years later, another billion. 12 years later, another billion. So what we're starting to recognize here is that the 20th century, the 1900s, was a time when we witnessed the most rapid population growth in human history. In 2011, we hit 7 billion during your lifetime, and it's believed in about 4 years we're going to exceed 8 billion people. By 2042, we're up to 9 billion, and then by 2050, it's believed we're going to be at about 9.9 billion. And many demographers, many people who study population statistics and trends and growth, believe that we're going to peak around 2050 as a global population. And again, we'll return to some of the reasons why that happens. But just looking at the last 200 years of human history, when we're talking about thousands and thousands of years of human history, we look at the last 200 years and we see an anticipated growth of 9 billion people. So that could bring us back to that question that Thomas Malthus posed a couple hundred years ago. Are there too many people on Earth? The list on the screen in front of you includes a number of definitions, a number of factors that we examine when we look at population growth and population change. Oftentimes population decline. CBR and CDR are crude, so they look at the entire population. They're not limiting the birth rate and the death rate to certain age groups. They're looking at your population as a whole, and they're saying how many people are born. Crude births are based on the number of live births per 1,000 people, and around the world today, this ranges from about 6 to 46. So we see a large range in birth rates around the world. The United States is at about 13, and the world CBR is at 20. So you'll notice that the United States has fewer births than the world's average. The death rate, on the other hand, looks at mortality, and the death rate around the world ranges from about 2 per thousand to about 23 per thousand. And the death rate itself can tell us a few different things about a country. It doesn't necessarily mean that a country is old or that a country is facing a serious pandemic. It just tells us the number of people that are dying. In Western European countries, countries with high median ages, we see that the death rate is rather high. In some sub-Saharan African countries like Lesotho, Botswana, where HIV/AIDS is a serious issue, we see that the death rate is high, but it's not because of old age, it's because of the spread of this disease. The natural increase of a population is simple arithmetic, CBR minus CDR. Now, an issue or a topic that often causes some confusion until students work through it is known as the total fertility rate, the TFR. And this is the average number of children a woman will have during her childbearing years. So this is age dependent. It's not a crude rate based on the entire population. And it looks at, again, the average number of children that a woman will have in her childbearing years. Now, the TFR is highest in places like sub-Saharan Africa, where we're pushing 6 and upwards of 7 average children per woman. And then in Western Europe and some of the city-states, the highly urbanized and industrialized countries in East Asia, we see TFRs that are below 1.5. The TFR in the United States is around 1.7, 1.8, which means that we are below replacement level, meaning that a country with the TFR below 2.1 would decline in the coming generations. Now, the United States is a little bit different because the United States relies heavily on in-migration. Most countries don't have the lopsided net migration scenario that the U.S. has. So the United States would experience population decline today and in the coming decades if it wasn't for migration. And when we look at population pyramids, we'll look at an example like Japan and Portugal, where these countries are experiencing population decline because they don't have in-migration. Their populations are aging, and the death rate will soon, if not already, exceed the birth rate. Infant mortality looks at the percentage of children that die in the first year of their life, and this oftentimes reflects social and economic conditions, where kids without access to medical care or mothers without access to proper medical care, in those areas we'll see a higher infant mortality rate. Life expectancy, again, another social factor, our average age at death, and around the world we see a large variance. In some of our sub-Saharan African countries, we've seen this dip down into the 40s and 50s, again, where HIV/AIDS is cutting people off in the prime of their life. In other areas, known as blue zones, we're seeing exceptionally high life expectancy. And in these areas, we find them in Japan, in parts of the Mediterranean, and parts of Central America. We see how community, diet, exercise, social involvement help people live long, prosperous lives. Where in other areas that are experiencing war, economic collapse, the spread of disease, social collapse, we're seeing that life expectancy in those areas is in fact dropping. When we look around the world, we break our population growth into developed and developing regions. Now, this is an overly simplified way of looking at regions, but our developing regions include China and India, and Southeast Asia, and Sub-Saharan Africa, and parts of Latin America. In our developing regions, we're seeing population growth occur at its most rapid rate. Our developed regions, Western Europe, North America, we're seeing those TFRs, those total fertility rates, drop below replacement level. We're seeing in some places, again, the death rate exceed the birth rate, and we're actually seeing those populations shrink a bit. This is our first look at the demographic transition model, and in part 2 of this discussion, we'll look at the different stages of the model. We'll identify countries that fall into those stages, and we'll look at the social and economic conditions and changes that are occurring within each stage. And we'll also look at benefits and issues that occur as countries move through this model.